CloudDB, shaping your new normal.
All right. Welcome everyone to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. Also, we will start getting the next couple of days in your agenda the replays of all sessions. That means you need to register to the sessions to attend, and then they will be populated information to your replays on your personal agenda. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and our main sponsor, CloudDB. Now for today's session, Oracle Global Data Services, GDS, Next Level Services for Application by IV Ravi Kumar. Please feel free to write questions at any time during the session by using the chat window on live webinar. It is in your bottom right corner of your screen. And Ravi will be answering all your questions at the end of the session. If there are any issues during the presentation, please feel free to contact me at any time using the same chat window at live webinar. Now, without any more delays, I would like to leave you with this amazing session by IV Ravi Kumar. Avi, this session is all yours.
Yeah. Thank you, Francisco. Are you able to hear me?
Yes, perfectly. I can hear you perfectly.
Yeah. So, good morning and good evening and good afternoon, some parts of the world. And thanks to APAC, OUG, and Francisco. This is my second opportunity to speak in APAC, OUG. So, today's the session is Oracle Global Data Services, GDS, the next level services for the application. So, introduction. My name is YV Ravi Kumar, Oracle Certified Master and Oracle ACE Director, and co-author of 100 plus Oracle Technology Network articles published in English, Portuguese, and Spanish languages. Twice the speaker at Oracle Open World, US, and I have co-authored with 3 books, Oracle-related books. One is Oracle Database Upgrade Migration Methods. One is for High Availability and Golden Gate with Microservices. And I'm a technical reviewer for forthcoming Oracle 19c Auto Upgrade Best Practices. So, 500 plus technical experts helping beats globally through our Oracle ACE program. So there are 3 levels in Oracle ACE program. One is Oracle ACE Associate, Oracle ACE, and Oracle ACE Director. So you can nominate yourself or someone you know based on your helping the community skills. They can nominate you as a one of the specialized award from Oracle. So today's session, Oracle Global Data Services with next level services for the application. So agenda. I'm going to explain my experience for past 2 years working for one of the government and healthcare, how they have implemented global data services for their applications. And we are going to see what are the test case scenarios we have tested in the production as well as development and other environments. So before getting into global data services, first I would like to explain the definition of service. All we know, the service, it is introduced by Oracle long back. So the database services are logical abstraction for managing workloads in Oracle databases. So services, we are not we are built on into the Oracle database and provide a single system image for workloads. You no need to install any particular softwares to getting into the features of services. So services can do enable administrators to configure a workload, and they can administrate, and they can even enable and disable. And the services is useful for measure the workload as a single entity when in terms of your workloads. So GDS allows maximizing the asset utilization for yielding the better performance and scalability and high availability for these workloads. So you might have seen in your cluster environments, we will be creating the services using the utility called SRVCTL, and you will be defining the preferred node, available node, where exactly it has to connect based on your workloads. For example, you have 4-node rack, you will be creating multiple services, one service for OLTP systems, maybe another services for data warehousing services. You can create multiple services so that when you connect through the service, the database connections will go to the particular environment. So clients connect using a database service name, instead of using SID, instead of using your database name, they will be connecting through service name, so that the service will aware of the workloads. For example, if you have 4-node rack, where exactly it has to connect based on your service type, based on your environment type, and based on workload, it will go to the particular node for access the database. So in real application clusters, a service can span one or more instances, and it will give you the workload balancing based on your real-time transaction performance. So this will give you high availability and any rolling changes by workload and full location transparency. So this is the normal way of working of services. Now we can see how the global data services are different from your usual services. So for replicated environments, GDS has introduced the concept of global data services. So your replicated environments can be through Oracle Golden Gate or Oracle Active Data Guard or any third-party software tools. So global data services can utilize the replicated environments. It can be a Golden Gate environment, it can be an Active Data Guard environment, it can be a third-party environment. So Oracle Golden Gate and Oracle Data Guard, we know, allow for distribution of application workloads across the replicated databases. So when applications are spread across geo-distributed databases, it is a challenge to efficiently use all the databases for best performance and availability. So we can use the GDS to efficiently use all the databases for best performance and availability if your databases are spread across geo-distributed. And global data services extend the traditional database services with an additional attributes such as global service placement and replication lag and region affinity. So this global data services is a new concept, and it will follow and it will support all the attributes supported by your traditional database services. what are the challenges when you use the normal services if your databases are spread across geo-distributed? So no seamless way to efficiently use all the databases, even though you have primary databases in one region and you have one active database, standby database in same region, and another active standby in different region. When it comes to normal services functionality, there is no automated load balancing, and there is no service high availability, and there is no complete centralized workload management. So based on these three challenges, application outages when the replicas fail. So workload on replicas managed in the Xylos format. So you are able to know now what is the services and the challenges. So in this screen, you are able to see, and left hand side, the normal services you are using on the primary database and the standby database using the replicated environment Golden Gate. On the right hand side, you are able to see the same functionality, but there is a framework between your application and database layer. That framework is nothing but Global Data Services Framework. And in left hand side screen, the sales service you are using on the primary database, the same set of services you are using at the physical standby. But here, when you are using the sales service, I'm not using for particular environment. So it will be connected to Global Data Services Configuration Framework. From there, based on the role, based on the region, it may go to the particular database environment. And you can see the complete architecture of GDS with the application layer. So you have two data centers, for example, first data center and second data center, and you have the load balancer, the first component, and followed by web servers, followed by your application server. Application server can be anything. So between the application server and database server, there is a framework to make utilize of the global services geo-distribution replicated environments. So the GSM, Global Service Managers, will be in between your application server layer and your database layer. So in normal services environment, you will not have the Global Data Services Framework. But in the Global Data Services Framework, you will have a middle middle component between the application server and database server using GDS. So the GSM, there is a separate software, Global Service Manager. You can see the left hand side Oracle 12c GSM software. When you say help, you can see all the commands using GDSCTL. So GDSCTL is a command line utility you can use for managing the environment of GDS. In right hand side, when you see when you say help, you can see all the set of commands introduced in 19c. So there is a vast difference between Oracle 12c and Oracle 19c. The lot of new commands are included in Oracle 19c. So what is GDS? So we discussed about the normal definition of service. Now we can see what is GDS. GDS does not itself perform data replication. Instead, it relays. So GDS will not do any data replication between physical standby and primary database. So it will relays on your replicated environments. Replicated environments can be implemented through Oracle Active Data Guard, or it can be through Oracle Golden Gate or any middleware software. So the second thing we should know, GDS does not perform any database failovers, but instead it relies on data guard broker. So GDS does not perform any data replication. GDF does not perform any database failovers. Number 3, GDS does not replace the functionality of your Oracle clusterware and Oracle RAC. And number 4, GDS does not coordinate with site failover, and the GDS works seamlessly with Oracle SiteGuard, the Oracle product that coordinates full site failover for both database and application types. And load balancing and service failover across multiple RAC-enabled systems and single instance databases that are replicated through your, either it can be a ADG or OGG or any third-party software tools. So connection and request load balancing is based on data consistency, response time, and location. Sorry. So it even supports active data guard, reader forms, as well as complex Golden Gate partition multi-master configurations. GDS works seamlessly with any combination of Oracle RAC databases, single instance databases. Even it works well with Oracle Data Guard, Active Data Guard, and Golden Gate. So GDS is a complementary technology to Oracle RAC, Active Data Guard, and Golden Gate. So where Oracle RAC allows scaling the application workloads on more than one node in a given cluster, but GDS allows scaling replication aware application workloads beyond the cluster. So where it supports, where and all you have implemented the replicated environments using Oracle ADG and Oracle GG, it will support. So the bottom line, GDS increases the return of investment of the replicated investments made by the customers with Oracle Golden Gate and Oracle Active Data Guard. Means the customers already they are utilizing the features Oracle Active Data Guard and Oracle Golden Gate. They can use global data services without any additional cost. So please remember this statement also. GDS is not limited to Oracle Active Data Guard or Oracle Golden Gate. Customers can choose their preferred replication technology for their Oracle databases, and still they can implement GDS to obtain the high availability and load balancing of their applications across the replicated databases. So the capabilities of GDS, on the right hand side, you are able to see there are 7 capabilities of GDS. One is a region-based workload routing, lag-based workload routing, connect time load balancing, runtime load balancing, inter-database failover, role-based global data services, centralized workload management. These are the services provided by global data services. In a normal service, these are the capabilities not applicable. So in the interest of time, I'm planning to show there are 2 test cases of GDS, how it works in real-time environments. So the first test case, global service failover. I have an environment, primary database, name ORCLDB. For that primary database, I have two physical standby databases implemented through Oracle Active Data Guard. So the two physical standby databases are ORCLDBS and ORCLDBP. So I have one primary database with two physical standby databases. So when you get into Data Guard Broker command line utility, when you say the show configuration, you can see the complete environment. In our example, you can see I have one primary database, two physical standby databases. So, sorry, we can see here, I will create a service on the, it should be available on physical standby databases. I will shut down first physical standby database and I will see where the service will connect. And I will also do the shutdown of second physical standby database, in our case ORCLDBS and ORCLDBP. Then when I try to connect, it has to connect to the primary database, because although you define the services, it should be available on the both the physical standby databases when it is available. When both physical standby databases are not available, when you are trying to connect through global data service, the service has to go to primary database, because we don't have physical standby databases are up and running. So I have one primary database and two physical standby databases. I have a global data service name called sales underscore reporting underscore SRVC service. So it is available for all the environments. In our case, one primary database and two physical standby databases. If it is not available in first physical standby database, your connections will go to second physical standby database. In our case, it is ORCLDBP. Sorry. So when both the physical standby databases are not available for some reason, when you try to connect service, it will automatically connect to your primary database. When both physical standby databases are up, then when you're trying to connect, again it will go to physical standby databases only. It will not go to your primary database. The reason behind, we are creating a service saying the properties like, when physical standby databases are available, it has to go to physical standby databases. When there are no physical standby databases, then it has to go to primary. So get into global data service control like SQL plus, like ASM CMD, like DGMGRL, they are all command line utilities. So even for global data services, there is a command line utility called GDS-CTL. So I will get into GDS-CTL. There is a catalog database. So I will get into that. Then I will check for first services. When you see the services, there is no services are available. So when you say databases, I am able to see three databases. One is ORCLDB with role primary in the region, primary region, and ORCLDBP role with the physical standby in the region C standby, and the third database, namely ORCLDBS with role physical standby in the region standby. So we have we have not yet created any services, but we have 3 databases. One is with primary role, and the other 2 are with physical standby databases role. So I will add a service with followed by service name and the preferred underscore all. I will say the role will be physical standby. So when physical standby databases are available, our service, sales reporting service, has to connect or has to go to physical standby databases only. When your physical standby databases are not available, then it has to fail over to primary database. So we are creating a service using the command called add service, and we will pass all the arguments related to your environment or based on your application requirement. So once the service is created, you have to start the service. So normally you will be creating the service SRVCTL, add service. Here for global data services, you are creating in GDS CTL command line utility. Means global data services is a framework. It will give you complete command line utility, and it will give you lot of sets of commands to perform all globally related commands related to GDS. So when you say services, it will show you, because we have given or we have assigned, I can say, physical standby databases, because we have passed the argument. We have passed one of the argument called the preferred. Based on the preferred role, your services up and running in ORCL DBS and ORCL DBP. When you say the databases, you can see the service database name, your service name, all those are the service is enabled, and it has not yet started at your primary database. If you see the first physical standby ORCL DBP, your service is enabled, your service is started. Same thing for Oracle ORCL DBS, service is started and preferred is yes, and it is enabled. So you have created the service with the preferred role, physical standby, and failover with primary. When you start the service, it will automatically start the service on the physical standby databases only. It won't start at primary database. Then you can see the details of sales reporting service using the command called config service. And you can see the bottom of the output. You can see the preferred status. What will be the status on primary database and what will be the status on our 2 physical standby databases. And when you get into SQL prompt, you can see the information about the global data services using 2 views called DBA underscore services and V active underscore services. When you say active underscore services, I am not able to see any global data services are up and running because this is primary database. When you query the one of our physical standby database ORCL DBS, you can see the sales reporting service is up and running in V active services. Even for second physical standby database ORCL DBP, I'm able to see the global data service, sales reporting service. It is up and running. So you can utilize two views, whether your global data services are enabled or not, or it is up or not, using DBA underscore services and V $active underscore services. And you can check the listener status also. So we created the global data service, namely sales underscore reporting underscore SRVC. When you check the listener status in primary database, I'm not able to see any global data services because we have created the global data service using the proper or preferred role on physical standby databases. But when you check the listener status in our physical standby databases, I am able to see the sales underscore reporting underscore SRVC. And this is normal, our TNS names entry, how we have defined sales reporting service based on your property, based on your region, all the other properties. But you can see our normal listener, the port will be 1521 is a standard port. But here for global data services, you can define your own port. In our case, I have defined 1571 for primary database, 1572 for first physical standby database, 1573 for second physical standby database. As we discussed, we have one primary database and two physical standby databases. Now, I will try to shut down one of the physical standby database, OracleDS. I will give normal shutdown command. Then I will get into GDS CTL. I will check the services and databases information. When I say services, previously it was showing two physical standby databases because it was available on the both physical standby databases. Now it is available only in second physical standby database because first physical standby database we have given shutdown immediate command. When you say the databases information, I can see in primary, we know that it has not started, and because of your shutdown command in one of the physical standby database, it is showing the started no. So it is only now available in one of the physical standby database, namely ORCLDP. Now, when I try to connect using sales reporting service, it has to go to physical standby database only. In our case, we have ORCLDBS and ORCLDBP because we have defined preferred role physical standby databases, and we know we have shut down. We have given shutdown command in ORCLDBS. Now the only physical standby database is available, namely ORCLDBP. When you try to connect the global service, it will go to the available physical standby database, in our case ORCLDBP. Then we will do one more shutdown immediate in a second physical standby database. So we have second physical standby database ORCLDBP. So we will shut down that physical standby database also. Now, although our service preferred role is physical standby databases, because of these shutdown immediate commands, both physical standby databases are down. Now you try to connect, we will see where exactly it will go. Before that, you check the services and databases using the GDS CTL command line utility. When I say the services, previously it was showing both the physical standby databases. Now you are able to see the primary database. And you can see both the physical standby databases are down. So here it is showing started N. And now you see the property has changed from N to Y in your primary database, because although we define global services, preferred role physical standby databases, and failover to primary, because of shutdown immediate commands in physical standby databases, automatically, please underline the name, automatically, it has started in primary database. That is what we defined while creating the global data service. We have given preferred role, physical standby, and we have given the property called failover primary. Means when your physical standby databases are not available, it has to go to, or it has to fail over to your primary database. Because of shutdown immediate on the both physical standby databases, when I check the services and databases, it is showing it is available in the primary database. In our case, the primary database is OracleDB. So when I try to connect, it will connect to your primary database. And now you check the V active services. Previously it was showing a global no. Now it is showing global yes. Because now the service, our global service, our global database, global data service is available on the primary database. So, and again, I will restart both the physical standby databases. After restarting both the physical standby databases, getting to GDS CTL, check once again services and databases, the command. You can see after restarting both the physical standby databases, automatically your global data services will pointing to again physical standby database. Here you have to underline one thing: we are not relocating the service manually. Please keep it in mind. We are not relocating manually. When you restart both the physical standby databases, your service, in our case, sales reporting service, automatically will start on the both the physical standby databases, and it automatically turns into Y into no, means N. So now if you see here, the services, it is showing up and running in OracleDBS and OracleDBP. Previously, when both the physical standby databases are not available, it was showing the output. When you say services, it was showing your primary database OracleDB. So when you restart the both physical standby databases, you no need to relocate. It automatically shut down the service in primary database, and it will automatically start the service in all physical standby databases. That is what we have defined in the add service command in GDS CTL command prompt. So the summary of this test case: your services automatically fail over. This is the capability of GDS. Because of this global service failover property, you can achieve higher availability and improved manageability. And we have seen, once your physical standby databases are up, we are not relocating the service from primary database to physical standby databases, automatically it will turns into property role. Then that is the first test case, global service failover. Now we can see one more test case called a replication lag based routing. Means sometimes in your data guard environment, your physical standby databases may lag behind with the primary databases due to various reasons, maybe network issue, maybe your physical standby database you have taken shutdown immediate for some reason, and we have again you have started. So for some reason there is a lag between your primary and physical standby databases. So here the replication lag based routing will help you, or we can define if the replication lag exceeds the lag limit, so and so lag limit, the global service is relocated to another available database that lags below the threshold. Means, for example, I will give the lag limit 10 for first physical standby database. For second physical standby database, some other number. Once the lag limit exceeds, although the service is available in both the first standby databases, when you are trying to connect, it will go to another available database where the lags below the threshold. So we can see now. So when you get into DGM GRL, I have show configuration command. You have one primary database ORCLDB and two physical standby databases ORCLDBS and DBP. So far so good. So when the replication lag exceeded the threshold on this physical standby, it will go to here. So when these two lag exceeds, it may go to, or not may, it will go to primary database. So first check the databases. I have one primary with two physical standby databases in different regions. One region is primary, C standby and standby. Then I will create a service sales reader lag 15. Means I am defining the lag. So preferred all, it has to go to physical standby. I am specifying the lag. When lag exceeds this number, it has to fail over to primary database. Although your service preferred role is physical standby, preferred all means it has to be there in all three. Means in our case, one primary, two physical standby databases. So preferred all means it will be available in your primary database and two physical standby databases. But role we are defining physical standby means although you have one primary, two physical standby databases, when you are trying to connect, the preferred role will be physical standby. When physical standby databases are not available, then you fail over to primary. This is the meaning of this command. So here we are specifying the including the lag. So when I say the service, and I will start the service, when I say the services, although preferred all, the role is physical standby, so it will be up and running in two physical standby databases, and you can see started equal to N for primary database, started equal to S for two physical standby databases. And you can see the service configuration. It will show you the preferred yes for all three, and the status enabled in all three. But the preferred, here you can see the role physical standby. And you can see the show configuration, and I will check the show database. The apply is on for one of the physical standby database, there is no lag. Even for second physical standby database, both are in sync. There is no lag between primary and two physical standby databases. In our case, one ORCL DBS and the second one is ORCL DBP. There is no lag between these two physical standby databases and the primary database ORCL DB. Then I will give the command apply off. So I will do the apply off for both physical standby databases. Then I can see the lag. So wait for because the lag you specified in when you're adding the service, it will be in seconds. So we have given apply off means we are not going to apply the archive logs for both the physical standby databases for 15 seconds. So wait for 15 seconds and run the services command. We can see where exactly it will be pointing to. So we have given set state apply off for both the physical standby databases and when you check the service configuration, it is showing now it is available in ORCLDB because there is a lag between your ORCLDB and two other physical standby databases. When you see the databases, it is started yes in primary, it is showing a started no in two other physical standby databases. Then when you try to connect using sales reader lag 15 service, it will connect to your primary database because you have a lag between your primary database and your two physical standby databases more than 15 seconds because we have defined the lag when you're creating the service, and we know we have given a set apply off for both the physical standby databases. So because of lag exceeds more than 15 seconds, when you try to connect with that service, there is no other go. You have given failover equal to primary. When you are creating the service, it will go to primary database only. Then now you start the archive logs to apply between primary and both the physical standby databases. So set state apply on for both ORCL DBS and ORCL DBP. Now your primary and the two physical standby databases are in sync state. Okay. Then when you say the services, it is showing all three. So slowly, so here it is showing when you say services, it is showing all three, and it is showing all three started Y. Once the synchronization is complete, when your lag is less than 15 seconds, wait for some time, then you give the same command services and databases, and you can see here there is no primary database ORCLDB because the lag is less than 15 seconds. So it took some time to synchronize your primary database with two physical standby databases. Once the lag is less than 15 seconds, automatically when you say the services and databases command in GDS CTL command line utility, you can see again only the physical standby databases in services, and in databases you can see started Y and primary started no. Sorry. Then Then when you try to connect, once the lag is less than 15 seconds, it can connect to either one of the physical standby database. In our case, ORCL DBS is one of the physical standby database. I am able to see it has connected to, instead of primary database, it has connected to physical standby database. So this test case we have seen, we have defined when there is a lag between your primary database and physical standby databases, it has to go to available database. It can be your primary database also. So because of this configuration, you can achieve applications perform well with better data quality. Means GDS will ensure that the service runs on active data guard. It will check the lag. If less than that, or if your lag is exceeded, defined in the service level, it will go to the available database. When the lag is in a right boundary, then it won't go to primary database, although you have given failover equal to primary. So based on lag defined service level property, it will go to the available database. When the service level lag you are specifying at the command level, automatically it will go to physical standby databases only, because you are giving, although you are giving preferred all, but you are defining the role first physical standby. When physical standby databases are not available, based on the lag you specified, it will go to the primary. So in summary, normal services cannot scale up in the geo-distributed databases. In global data services, there is a framework between your application layer and database layer. And global data services you can utilize when you are replicating the environments using Oracle Active Data Guard, Oracle Golden Gate, any other third-party software utilities. It will work for that also. And global services, global data services will be using all the attributes of your traditional services. And we have seen in our session, there are a lot of features, but here I am able to demonstrate. One is a global service failover. Second one is lag-based replication. So these are the two scenarios we have seen using global data services. And as we discussed and as we said, GDS is not a replication tool, and the GDS is not a replacement for any clusterware, and the GDS is not will do any failovers. GDS is a complementary tool. It will relocate your services based on your defined properties in geo-distributed environments. That is the only definition we can give global data services. So using global data services, I can utilize the services using when you are connecting through your applications based on workload, based on role, based on lag, where exactly it has to point to. So your services will be well defined with global data services, so that you will not have any downtime when there is a downtime for your physical standby. That is when you are using for any data warehouse capabilities for physical standby, You no need to relocate the service to some other database or to the primary database. You no need to do anything. You automatically, when you define the service with all the attributes in GDS CTL format, command line utility, that will take care of your role and your failover capabilities, everything. So I hope this session is useful many application related folks, because we are till now we have seen the manual services, how it will act when coming to the environments, critical environments, and how the global data services we can utilize when your databases are spread over geo distributed environments, and we can define a lot of attributes to eliminate your downtime. So if any questions or if any queries, please feel free to post, and I will try to answer all your queries. And thanks for your time once again, and thanks for APAC OUG for this opportunity, and thanks to Francisco for this opportunity. So
no questions. We had no questions during the session. That's not a problem. If we have any questions, they will be contacting you through your email or through us or through Twitter. And we also, during the replays, if you have any questions, you can contact Ravi directly or through the APAC OUC. And saying that, Ravi, thank you so much for giving the time to present this session today. And please take care and be safe on these pandemic times.
Thank you, Francisco. Thanks once again, APAC OUG.
Thank you. Have a wonderful day, everyone.
CloudDB, shaping your new normal.